Okay, good morning, good afternoon, and good night to everybody. This is the third class for the Physics 1 course. And today's chapter is Gravitation and Gravity. So in this chapter, we'll discuss about the historical background of gravitation. Actually, the founder of this gravitation is the Newtons, you must know. And we'll discuss what is gravity and gravitation, Newton's law of gravitation, Kepler's law of planetary motion, and you have to find the value of z. Z means what? The acceleration due to gravity. And oscillation of compound pendulum, then gravitational potential energy, and we also discuss about the gravitational field and escape velocity, and at the end of this class will derive the laws of gravitation. So actually we are discussing about the Newtonian gravity here. This is the actually classical definition of gravity. Now you must know Sir Isaac Newton was not the first to discover gravity. Newton discovered that gravity is universal. Legend Newton, sitting under an apple tree, realizes that the Earth's pull on an apple extends also to pull on the moon. That means this is the historical background behind the discovery of gravity. This is the actually universal gravitation he discovered. So what was the actually universal law of gravitation? In Aristotle's time, motion of planets and stars was natural, not governed by the same laws as objects on Earth. And Newton recognized that a force directed towards the sun must act on the planets. This is similar to force that Earth exerts on an apple that falls forward it. The same set of law apply to both celestial and terrestrial objects. That means in planetary motion, this is the actually Earth and this is the moon. So the attraction between these two happening, the motion actually creating the day and night and year for our Earth. So and tide also happening due to the attraction of moon and Earth. This is the actual universal law of gravitation. So Sir Isaac Newton actually says what? Sir Isaac Newton says Isaac was what about the moon and Earth? That means attraction between moon and Earth. So Isaac Newton was the first person to hypothesize that the force that pulls on an apple to the ground also pulls the moon towards the Earth, keeping it in an orbit. Okay, this is the actually falling apple on the head of Newton, and she calculating this force. This one. So first of all, what is gravity? Actually, gravity is a force that attracts all objects toward each other. So this is the definition of gravity. Gravity is a force that attracts all objects toward each other. That means in these objects, Earth must be present. Now the force of gravity is measured in Newton. Now mass versus weight. Mass, what is actually mass? This is the amount of matter in an object. Amount, padarthir puriman. Okay, bhor bole. Mass means bhor. And weight means what? Ojon is the force of gravity on an object. This is one kind of force. Weight means what? One kind of force. The greater the mass, the greater force, weight. That means if the mass is greater, then force will be also greater. Now, without air resistance, everything falls at the same speed. It's called free fall. It just so happened that on Earth, free fall has an acceleration of 9.81 meter per second square. This means we can calculate the weight. So weight is a force and weight is equal to the mass time acceleration free fall. That means W equals to mc. So you can easily uh, calculate the weight of any body. Now, gravity of two objects. Any two objects will exert a gravitational pull on each other. So why does the Earth not move towards us? So the gravity, the strength of gravity between two objects depends on two factors. One is masses of the objects, and second one is the distance between the objects. Okay, so this is the actually example for this. That means 1 million kilometer and 3 million kilometers. So distance is bigger here and distance is a little bit. So this distance between second two objects is 3 times larger. Okay, 3 times larger distance. Therefore, the strength of attraction between the second two objects is 9 times smaller than the attraction. So gravity, the greater distance, the less the gravity between the objects. Attraction will be lesser. And the greater of masses, the greater the gravity between two objects. That means if the mass is bigger, then gravity can becomes bigger. But the distance between two objects is greater, then gravity lesser. Okay. So we can see here. So laws of gravitation, what Newton realized that this relationship between mass, distance, and gravity could be mathematically shown and like this: F equals to Z multiplication of two masses m1 and m2, and distance between is this. So why do Earth and the Moon remain in their orbits? Actually, inertia and gravity combine to keep Earth in orbit around the Sun and Moon in orbit around the Earth. The combination of gravity and inertia keeps the Moon in orbit around the Earth. If there were no gravity, inertia would cause the Moon to travel in a straight line. If only gravity existed, the Earth would be pulled into the Sun. That means the Moon will disappear from Earth. So the gravitational pull between the Moon and Earth, this is the Sun and this is the Earth and this is the Moon. This is an orbit. So the attraction between Sun and Earth, the gravitational pull between Sun and Earth, and the gravitational pull between the Earth and Moon. So the universal law of gravitation can be a state like this: laws of gravitation, universal gravitation, everything pulls on everything else. That means this is a rocket and going, leaving the Earth. So everything pulls on everything else. Everybody attracts in this universe, everybody attracts each other with a force. Okay, that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, so or separating them. This is the actually laws, universal laws of gravitation of Newton. So mathematically we can write F equals to Z, m product of their masses, and inversely proportional to the square of the distance between them. Then where m is the masses of the objects and d is the distance between their centers. So examples: the greater the masses m1 and m2 of two bodies, the greater of the force of attraction between them. That means the if the masses increases, then the force will be increases. So the greater of the distance separated d and weaker force of attraction. This is actually we are talking about the universal law of gravitation of Newton. So in this universal law of gravitation, there is a great constant, capital G. The gravity is the weakest of four known fundamental forces. That means with gravitational constant G, we have the equation F equal to G into this. So universal constant, capital Z, equals to, this is the constant, 6.673 into 10 to the power minus 11 Newton meter square per kg square. So once the value was known, the mass of the earth can be calculated, and the mass will be 6 into 10 to the power 24 kilogram. So gravity and distance, the inverse square law. Inverse square law related the intensity of an effects of the inverse square of the distance. So intensity equals to 1 by distance square. For increase the distance, there are decreases of force. Even a greater distance force approaches but never reaches zero. So from this, what is gravity? So Newton's law of gravitation can be stated that any particle of matter in the universe attract any other with a force varying directly as the product of their masses and inversely as the square of the distance between them. So this is actually universal gravitational constant found on physical constant here, Fz equals to for the earth. We can calculate this for the earth, Fz equals to Z product of their masses and distance between them. This is the moon and this is the distance from the earth. This is the first masses and this is the second masses. So the acting force F equals to Zm1 m2 divided by r square. Distance between the centers of the two objects in meters. And here capital Z equals 6.673 into 10 to the power minus 11 Newton meter square per kg square. This is actually this attraction, and this is an orbit and path of the moon would naturally takes. This is actually physical interpretation of Newton's law of gravitation. Now, what will be the Newton's law of gravitation? It states that every body in the universe attract every other body with a force which is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. That means F is proportional to m1, m2 and F equals to 1 by r square. This is actually these two relation from the Newton laws of gravitation. So F equals to proportional to m1, m2 divided by r square. And after removing proportionality, we have to add a proportionality constant, capital Z, which is called universal gravitational constant. Here capital Z equals to 6.67 10 to the minus 11 Newton. Dimension will be what? M capital M to the power minus 1 L cube. Now, first difference between gravitation and gravity. Gravitation, it can be attract force or repulsive force. Gravity is always attraction. That means the force attached to the center of the earth. It is universal force and the force of gravity by an force, and it is not because the earth is the other force. It is a weak force and it is a strong force. The force is equal to m1 and the force is equal to mc by 6 now. Another one, The direction of the force lies in the of the masses. The direction of force is along the arc center and the center of the body. Its direction is towards the center of the arc. Gravitation force is a vector and gravity is also a field. The force can be zero when it's the direction. The force of gravity can be zero at the center of the arc. Now it requires masses and it requires only one mass. So the Newton's laws states that every body is center if the other both which is directly proportional to the product of the masses and is vast proportional to the square of the mass. If there are two bodies on that mass and one and mass and two and they attraction force F their distance and R, then F this force is proportional to the product of their masses and plus square of the mass square of the distance. So combined and this by this capital is the proportional constant that is called the universal constant. And z is equal to 6.67 minus 7 Newton meters per kg square at dimension of c capital M to the power minus 1 capital L cube and capital. Remember that the dimension always represented the capital M. So the value of capital Z is the same throughout the Z does not depend on the nature and size of the bodies and nature of the medium between them. So you have to remember this. Now vector forms of Newton's laws of gravitation. So now the vector forms will be the, so what will be the vector form? Then the gravitational force is vector form is the force between first mass and second mass will be negative Gm1 m2 divided by r2, and this is the unit vector, and this is also from second mass to first mass. Here negative sign shows that the gravitational force is attractive in match. Attractive in match. Note that gravitational force are central forces as they act along the line joining the centers of the bodies. Another one, the gravitational force are conservative forces. So work done by the gravitational force does not depend upon the path. The total gravitational force on one particle due to the number of other particles is the resultant of the forces of attraction exerted on the given particle due to the individual particles. So the total sum will be total force. Sum of forces will be at one particular, as it follows the principles of superposition. Now we have to now another one is the force is attracted exerted by the exert body is called gravity. The force of attraction exerted by the earth body is called gravitation. The acceleration produced in the motion of a body under the effects of the gravity is called acceleration due to gravity, and it is denoted by small v. Let a body of mass m lying on the surface of Earth, then the gravitational force of capital F gmm by r square. Here m is the mass of the Earth, and a small m is the another body of the mass which lies on the Earth, and r is the distance between the center of the Earth mass. So where mass m and capital R are mass radius of the Earth. Okay, if Z is the acceleration due to gravity, then the force on the body due to the Earth is equals to m. Remember it, the acceleration due to gravity and m equals to here is why Z equals to Gm by R. That means the body depends. Z depends, does not depends on the body of the mass. So in forms of density, you can write C equals to capital C divided by R square 4 by 3 pi R cube. Because 4 by 3 pi R cube is the actually volume of R. This is why small c can be divided by like this. That means this is proportional to rho R. It's the density of the R. Now we will find out the variation in gravitational acceleration c z. Now due to the altitudes, that is height, this is the actually r, and who is the center of the r, and this is the capital R is the radius of the r, and z here, z value is the acceleration due to gravity, and after the height is the altitudes will be a's, and here the gravitation acceleration due to gravity is acceleration due to gravity at the surface of the earth is this. We have calculated earlier. Acceleration due to the gravity at the height is from the surface of the earth will be z dash equals to z by r plus a. That is total distance. Capital R, small r. So hence z dash equals to can be written as z into r by r plus a whole square. Okay? Or z dash equals to z into r plus. Actually, this can be written as the class of -2. That means z dash can be written as z into 1 plus h by r. Actually, we have expanded here by the binomial series or by expansion, and omitting the higher order of the series, we get z dash equals to z into 1 plus h by r. If binomial theorem, we get this one after expand. Okay, z equals to 1 minus 2 h squared by r. Note that the above formula is valid if base is up to 5% of the arc radius, that means 320 km. If base is the greater than 5% of the arc radius, is only height, acceleration due to gravity, and height a is will be gm by r plus a whole square. So this is the so the above surface of the earth at the point which is located at a height a is above the earth's surface, acceleration due to gravity c is given by this. So z dash equals to z into r plus a whole square. Now we can calculate the value the surface of the earth. Suppose this is the whole earth, just below the a's distance, and we can draw another sphere similar to the earth. Then the radius of the new sphere will be r minus 6. So let we place a mass m at the depth h below the surface of the earth. This mass m is attracted towards the center of the earth by a gravitational force due to the shaded sphere of r minus 6. The net gravitational force on m due to the remaining portion outside the shaded portion is 0. Let the mass of the shaded portion is m dash. Assume that the earth is a sphere of uniform density d, then d equals to mass per volume. Okay, density equals to what? Mass per volume. That means density equals to mass divided by volume of the earth. 4 by 3 pi r cube. This will be pi r cube. Right? Stick. And m dash equals to volume of shaded part density. So m dash equals to 4 by 3 pi r minus a whole cube multiply m 4 by 3 pi r cube. That means we get this equation. The net force on m equals to force exerted by the shaded portion. That means force according to the law of gravitation for the shaded circle. We get this. So we get the formula z dash equals to z to 1 minus a by r, where z is the acceleration due to gravity. It should be noted the value of z decrease if we move above the surface or below the earth. That means আমরা পৃথিবীর উপরেও যাই না কেন, নিচে যাই না কেন, z এর মান কমতে থাকে। Now we can also calculate with the latitudes. Consider the point A on the Earth surface where joining the center O to A makes an angle theta with the equilateral plane shown here, and we can resultant by the masses by capital F equals to first mass, first weight, second weight. Then this is the actually cosine laws of uh, mm, of resultant, okay, of two forces. So effective gravity we can be written by like this. So at pole theta equals to 90 degree and z equals to 0. That means at pole acceleration due to gravity is equal. But at equator theta equals to 0 degree. In that case we get the equation below of z will be like this. Similarly, escape velocity we can determine the escape velocity of a rocket just using the uh, equation of the kinetic energy half mv square. Okay, and we can also find out the motion of a satellite around the earth. Motion of a satellite. This is the satellite. Okay. Motion of a satellite, and this is the time period of that. Now we can describe the acceleration due to gravity like this. Actually, we have this one in our previous part. Now, there is a simple math. A body of weight 90 kg on the surface of the Earth. How much will be its weight on the surface of the Mars, whose mass is 119 and radius will be half of that of the Earth. That means we can write, we can use the Newton's law of gravitation. Okay, this is the capital M is the mass of the Mars. Okay, Mongol block. So just using the query, we get the mass of the Mars. This is the mass of the planet is 3 times that of the Earth, and the diameter of the planet is also 3 times that of the Earth. What is the acceleration due to the gravity on the surface of the planet? Volume of z on the Earth's surface is 9.8. So just using acceleration due to gravity is equals to 9 m by r square equation 1, and z dash equals to m by r dash square. So just dividing by these two, get m dash by m, but the ratio of radius would be 1 by 3 and z equals to 9.8 should get the z dash. Similarly, we can find out the radius. Now derive expression of the oscillation compound pendulum. Okay. Now this is the a compound pendulum is rigid masses masses capable of oscillating about a horizontal axis passing through any point of the mass. This point is called the point of the suspension. This is the S point. So this is the L, and this is the equilibrium position, and Z indicate the weight of the pendulum, the point. So let the moment of the inertia of the pendulum about the axis passing through the S particular its and B I. So this is the moment of inertia, and angular acceleration will be this. So this is the differential equation for the I into d square to the by d square to minus mc outside. So negative sign shows that the force is directed towards the main position. Okay, equilibrium position. So this is I d square theta minus d square plus mc sin theta. For a small angular displacement, we can write sin theta equals theta. So in the case, we can write moment of inertia of the pendulum about the axis passing through as perpendicular to its plane would be mk square plus mls. So here k is the radius of the gyration about an axis passing through the center of the gravity and pendulum. So we can write I equals to this one. Just putting these values. This equation is similar to the equation of the simple harmonic motion. So where omega square equals to L squared by k square plus L square. But omega is the angular frequency. Time period equals to angular displacement divided by angular velocity. So twice by root over k square L square. It is 2 twice by where k square by L plus k square L plus small l is called the equivalent length of the simple pendulum. Now we have to discuss about the gravitational field, gravitational potential, gravitational acceleration. So first of all, what is the gravitational field? The space around the body of mass within which the gravitational force of attraction is perceived is called gravitational field. The gravitational field or intensity at a point is the force experienced by a unit mass at that point. That means force equals to m, where E is the gravitational field. So equals to F by m. Also, the gravitational field is defined as the negative gradient of the gravitational potential equals to negative gravitational potential dq by dx. So consider a particle A of mass m, p is a point of distance r from A, the gravitational density by E equals to F by m and F equals to what? Gm by r square. Must just using the gravitational laws and Newton laws of gravitation. So, mm. So gravitational potential at a point is defined at the amount of work done is moving a unit mass from the point to infinity against the gravitational force. So in that case, intensity will be minus dp by dr and dp can be written as minus dp equals to and equals to putting the values minus m by x plus just equation 1. Okay. Now integrating between the limits infinity to r. So in r to infinity, and then I can write and get the just simple after simple integration we get this is the 0 something by infinity equal to 0 and this is y minus z by r. So the gravitational potential at a point due to the point mass is this. Its maximum and 0 at infinity is the maximum potential gravitational potential and will be 0 at infinity. So at all other points it is less than 0 at infinity. So the gravitational potential at a point is a scalar point. Now, another one, what is the gravitational potential energy? So the gravitational potential energy of the body of mass m at a point P will be equal to the product of the masses and the gravitational potential at point P. So potential energy will be mB. Okay. So when the gravitational potential energy of the body depends upon mass of the body at P and the distance between two masses. So now we can calculate the gravitational potential field due to the spherical sphere at a point outside the sphere and inside the sphere. So at the point outside the shell or a sphere. So consider the uniform spherical mass of m and radius a. Let rho be the density per unit area of the shell. The planes AC and BD cut the shell vertically and the element between two sphere is a ring of radius a equals to 8. Surface area will be what? Twice by S sin theta a. This is the surface area and twice pi a square sin theta theta. Mass of the element will be this. This is the surface area. So also F equals to X, the potential P due to the element dp equals to minus cm by x, dp equals to just put in the values. So just using the triangle laws, OAP x square equals to x square plus r square minus 2 say r cos theta. This is the actually cosine law for triangle ABC. So just using this one, just differentiating with respect to x. X square differentiation will be twice x dx and x equals to this one. Substituting these values of x in equation 1, we get the value dB. Now integrating for the whole shell, that means we have to integrate between r minus a to r plus to find out the the, uh, the intensity, the value of v between within radius a. So we get p equals to minus 4 pi a square rho c divided by r. M equals to what? 4 pi a square rho. Mass equals to surface area multiply density. So therefore b equals to minus cm by r. Thus for a point outside the shell, potential concentrate the center of the shell. So further b is proportional to minus 1 by r. Now gravitational field equals to minus dv by dr. So equals to minus ddr. Thus putting the value of b and e equals to minus cm r vector divided by r. The negative sign indicates that the field is towards the center of the shell. Now at the point inside a shell. So this is actually R, radius R, and inside the shell between the potential at a point inside the shell due to the element dp equals to minus twice pi c arrow r dx. So inside the shell we get a minus r to a plus r. So just integrating, we get the value of b will be minus 4 c 4 pi arrow m equals to 4 pi square root. So b equals to minus m by n. So expression 5, this equation indicates that b is the independent of r. That means it does not depend on the radius of the r. It is the same at all the points inside the shell. This potential is equal to the potential of the surface of the shell and this constant. Now gravitational field equals to minus dv by dr. Just putting the values. Okay, is a constant, so equals to 0. Therefore, the gravitational field at any point inside the spherical shell is 0. Now, what is escape velocity? The escape velocity is defined as the velocity with which a body has to be projected vertically upwards from the Earth's surface so that it escapes the Earth's gravitational field altogether. If b the escape velocity, then the initial kinetic energy will be half m square, must be equal to the work done in moving the body. So from the surface of the Earth to infinity, in such a case, the body does not return to the Earth's surface. So mass of the Earth will be capital M, radius of the Earth will be capital R, constant of gravitation will be capital Z, mass of the body will be small m. So, suppose a body at a distance x from the Earth's center, the force of gravity acting on body will be Gmm by x square. If the body is to be moved through a small distance dx away from the Earth's surface, work done will be what? Force this Gmm by x square to dx. That means force multiply displacement. So work done is moving on a body from the surface of the Earth to infinity. That means from surface, the whole radius of the Earth will be R, and up to infinity. We have to integrate R to infinity. This equation 1. So just integrating, we get the whole work done. That is Gmm by R. Because something by infinity equal to 0, just putting the value of R with this. So this is actually 1 by x square formula minus 1 by x integration formula. Now total kinetic energy will be half mv square, but this total kinetic energy will be the work done of the unmanned drone or any vehicle on a rocket, etc. So Gmm by R equals to B equals to what? Root over Cm by R. But at the surface of the Earth, then equals to weight equals to Cm by R. Then Cm equals to Cr. Substituting these values of Cm in equation 4, we get B equals to root over 2i Cr. Now the value of Z of the Earth will be 9.8 and radius of the Earth will be 64 into 10 to the power 5 meter. So we can calculate the escape velocity equals to root over 2 Cr. Just put it. And this is the 11.2 per second. Now we can find some with what velocity should a body be projected vertically towards from the surface of the Earth so that it may just attain a height of half of the radius of the Earth, and as the radius of the Earth are equals to 6400 kilometers. Now the work done will be the moving body from the surface of the Earth will be half of the radius of the Earth. So work done will be radius to surface to 2/3 of that. This is why just integrating we get this one, and kinetic also half mv square. So this kinetic energy will be involved in the work done. So you get equation 1. At the surface of the Earth, weight equals to the force. So m is equals to, and m will be cancelled from both sides. We get this one Zb equals to this one. Just putting the values of C R, we get escape velocity will be 6.467 millimeters. Similarly, an artificial satellite is circling around the Earth at a distance of 900 kilometers from the surface. Calculate its velocity and the period of revolution radius of the Earth. So just putting the values from the problems, we get the result. Time period will be this. Now derivation of law of gravitation, how we can derive this. Suppose the mass of the planet A is m1 and the radius of its orbit will be r1. The time period of the revolution will be t1. So it is assumed that the orbit is circular and the force of attraction exerted by the sun on the planet will be centripetal force, Kendramukhi force. So F1 equals to mr. This is actually circular velocity mb. F equals to so m1 r1 omega naught whole square. So F1 equals to m1 r1 omega means what? Twice pi by t whole square. Similarly, for the second planet, B of mass m2, radius r2, we get like this. So just dividing one equation by 2, we get this one. But according to the Kepler's law, we get this relation. Substituting these values in the equation, we get this is the constant. So force will be mass divided by r square. That means force proportional to mass, but force inversely proportional to the square of the distance. So now we'll discuss Kepler's law. Kepler's laws of motion. Kepler law determined that the orbits of the planets are not perfect circles but ellipses with the sun at one focus. That means sun, this is sun and this is the planet. So sun will be the center. So now Kepler's second law. Kepler's determined that a planet moves faster than near the sun and slower when far from the sun. This is the faster when near, but slower when far. So this why Kepler's law provided a complete kinematical description of the planetary motion, including the motion of the planetary satellite like the moon. But why did they actually the apple and the moon? This is Isaac Newton realized this motion of the falling apple and the motion of the moon, both actually the same motion caused by the same force and the gravitational force. So the universal gravitation, this is the universal gravitation, and this is the weight of the apple will be gravitational force. That means W equals to mc. So, and weight of the moon will be also can be calculated like this newtons. So weight of the moon will be Newton's calculation showed that the centripetal force needed for the moon's motion about was 1 by 3600 of mass of the weight of that. So this is the calculation. Now universal gravitation, and this is the universal law of gravitation. So inverse square law, and so the inverse square force can be calculated by graphically. Okay. And gravitational field also can be defined like this. And so this is the simply gravitational field, and gravitational field strength will be equals to F by m. So we have calculated this one. And gravitational field inside the planet, inside a planet, and we have also calculated this. This is actually definition of black hole. Black hole gravitational force and black hole gravitational force. And why it's happened tight due to the moon attraction of moon. Why two tides? One with the sun, another one with the moon. So this is actually why tides. This is actually a real life application of gravitational loss of motion. Gravitational loss of Newton's gravitational loss of gravitation, and by the moon. This is the gravitational potential due to the point mass. have calculated, and another gravitational potential at a point due to the ring. And another one is gravitational potential at a point due to the spherical shell, hollow sphere. We have calculated this. This is for another method. The gravitational potential due to the homogeneous solid sphere. We can use this method also here. A gravitational potential energy